Read Write World. I'd like you to all give him a huge hand. Blaise Aguera y Arcas. Thank you very much. Thanks, Blaise.
Good. All right. So I'm here to give you a much longer talk than I'm usually allowed to give. So we've got an hour, and we'll use a little bit of it for Q&A at the end. It's really very nice and unusual to be able to take a proper amount of time to talk about the sorts of things that I'd like to share with you. The center of what I'd like to talk about is an initiative that we launched just a few weeks ago called Read Write World. And this is the logical extension and continuation of work that we've been doing for several years, starting in 2006. So it's been 5 years now. We began this right after I joined Microsoft, right after the startup that I had founded, Seadragon, was acquired by Live Labs in 2006. And it's proceeded since then with some fits and starts. In the meantime, I shifted over from Live Labs to become the architect of Bing Maps and Bing Mobile. We started up the mobile division of Bing, which has been a really interesting journey. I tried to think about exactly what search means in a mobile context. It's very, very different from just a normal web search engine, a website, and this is really sort of going back to roots in some sense, going back to some of the first things that we were dreaming about in Live Labs, and saying, okay, how do we actually move this forward? How do we make this real? So this is a rough outline of the things that I'll be talking about. So first, a little bit of a retrospective on photosynth from 2008 to present. Then zoom out a little bit and talk about spatial media. Spatial media includes, of course, all sorts of things. I'll be focusing mostly on the pixel variety of spatial media, so imagery of one sort or another that's associated with space. And then these future concepts that we've been calling reality mashup and other sorts of things, what we can do to take all of these different kinds of media and experiences and platforms and put them together and do transformative things, enable transformative things in the community most of all. So photosynth launched in 2008, in August of 2008, and I'm sure many of you know what this thing was. The idea behind photosynth was to take groups of photos that you upload. While you're uploading them, your computer is doing this computer vision processing and stitching together those images into a three-dimensional environment. This is something that took a lot of people by surprise when we first released it. It didn't take the researchers in the field of computer vision so much by surprise, because that's been a steady evolution in technical capability. I should pull up, for some of you it may have been a long time since you saw photosynth, so I'll pull up the website, and I'll pull up some of my own synths to give you a sense or remind you of what this thing was all about. This is a synth that I took in the summer of 2008 of our old nanny, Jessie, who is living in Portland now, in fact. So the way it begins is as a series of, in this case, 75 pictures that I took of her sitting on a dock in Woods Hole, Massachusetts. And these were I just took them with a regular $100 digital camera. And I told her to sit still, but she didn't totally sit still. And as I took those photos, so I'm taking them in a way that they overlap a lot, so that there's plenty of connection between those photos visually. And while the photos were uploading to the photosynth site, my computer was doing this calculation, and the output of the calculation was twofold. First of all, you get this thing called a point cloud out. So this is a very rudimentary three-dimensional model of Jessie, reconstructed from those photos. It's just a cloud of points. And what you also get is the relationship between that three-dimensional model and all of the images. So you have ways of navigating amongst the images in 3 dimensions. So here I'm rotating around an object, all right? So it detects that Jessie is an object because I shot around her in a circular pattern. And there are close-ups. So these rectangles represent places where I shot close-up images. And there's another, and another, and another. It's also using the Sea-Dragon multi-resolution technology, which is kind of fun, which means that I can zoom in and see a tremendous amount of detail, perhaps more detail than you want to see. So really what it's about is, I mean, we imagined this being like a new kind of medium. It's not video, it's not image, it's something else. It's a collection of photos that forms some aggregation that represents a three-dimensional environment. It's not quite a three-dimensional model either. It's something else. We called it a photosynth. So the idea, of course, I mean, once you start getting into this idea of making photosynths, so many people started making photosynths when we launched, and a community built up around photosynthers. Of course, a lot of the things that are good to synth are architectural things and places in the world, things that exist in space and that are bound to the world tightly in some way or another, like a building or a statue or a place. Of course, there are also synths of people, there are synths of banana peels, there are synths of whatever, but these geospatially bound things were especially interesting to us, because part of the vision for this was to think about how mapping the world becomes a collective activity in which we don't think only about the kind of top-down mapping in which Microsoft or Google or other companies go and drive the streets and fly the planes and so on, but in which everybody contributes collectively, and those media belong to the people who contribute collectively and yet are benefitable by everybody. Benefit, is that a word? That's a word. Benefit everybody, right? So in the same sense that Flickr is about sharing your photos, and they're your photos, but this is one place that you can go in which all those things are brought together, and you can explore, and you can see other people's work. Well, it'd be pretty interesting if you can explore the world in that way and experience other people's captures and experiences and places in the world in that way. And that was really a big part of the vision for photosynth, to mash it up with mapping. And we did to some degree, although I think the level of integration between photosynth and mapping is still not as great today as it could be. We did do. Let's see. We might as well pull up the mapping website and give you a bit of a sense for where that level of integration is today. So this is the maps/explore website, which is up in public now, and it lets you. Our connectivity is not as perfect as I would like, but it doesn't matter. Okay, so this is an alternate mapping website. So bing.com/maps or maps.bing.com is the main website. This is an alternate website that has a lot of extra stuff in it, kind of experimental. So let's search for the Met, New York. We fly into here. As we zoom into the Met, we start to get these stitched oblique views. Okay, and so this is all stuff that's stitched together from planes flying overhead, and we'll talk a little bit more about this kind of media shortly. If I click on the human scale button, then I see streets. So the streets in blue are streets where we've driven. Okay, so this is our street side stuff, and this is a little bit like Google's Street View, except we think ours is kind of a little bit cooler. But anyway. Okay, so that's our street side stuff, and the other thing that you see are these green zits. Okay, so the green zits are user contributed, and they're photosynths. So for example, this one is one that I've shown off a couple of times before. It's by one of the most avid synthers in New York. This particular guy, I think he may work at the Met. I'm not sure. And he took thousands of pictures. Well, he took 1,317 photos in this particular Greek and Roman wing of the Met. And those photos are enough that when you look at the point cloud from overhead that Photosynth was able to reconstruct, you can really see, I don't know how visible it is on the projector, but you can really see sort of the floor plan of the whole wing. In this overhead view, you can mouse over different parts of this environment, and you see those white cones are individual shots, individual photos. So if I click on one of those, then we'll dive in to that particular photo. And again, connectivity is not perfect, so we're not experiencing this perfectly. So these are different views on this statue, just like we were looking at different views of Jesse. So now these are bound to space and they're connected with the map. So this was an interesting step, and we showed this kind of stuff for the first time about a year ago, a little bit more than a year ago. I've never been totally happy with the navigation experience of photosynth. These quads, they work pretty well when what you have is a close-up of something else. If you're looking at a painting on a wall or something like this, then these white rectangles work pretty well for navigating you back and forth between photos. But it doesn't really feel like the three-dimensional experience that it could be. There's really still quite a big gap between photosynths that are captured in this way with an ordinary camera and the kind of immersive experiences that we can capture when we drive down the streets with these panoramic cameras on the tops of the cars. And of course, the difference is that space is big. Space is roughly six-dimensional when you think about it from a photographic point of view. A particular image has a location in space, x, y, and z, and it also has a direction that you're shooting in, theta, phi, and omega. So that's 6 dimensions, and 6 dimensions is a lot to cover. In particular, if you want to have a sense of being in a place, being immersed in a place, our field of view is very wide. We're looking at almost a half a sphere worth of visual information, even though the fovea, the part where you really see the details, is quite small and is only in the center of your field of view. For your immersion, you really have this sense of an entire half sphere, and with a small movement of my head, I can see 360 degrees, or I can see everywhere around me. And photosynth is not particularly good at giving you that immersive sense. It's a little better at objects, not as good at giving you that immersive sense. So anyway, I'll return to that idea in just a moment. But first week that photosynth.com was online in 2008, this was a search for Trevi. So looking for synths of the Trevi fountain. There were dozens of people had created synths of the Trevi fountain. Dozens of people had made synths of the Eiffel Tower, or of Chichen Itza, or of Tulum, or of Angkor Wat. So there's really a lot of collective visual knowledge about the world embodied in these synths. So this is the Leaning Tower of Pisa, or Petra. Most of these are of the counting house in Petra, just in front of the Sikh, that very famous view, or Bryce Canyon. Right, so a lot of the world is now in one form or another. A lot of let's say visually interesting parts of the world are represented in photosynth somewhere. Well, okay, so let's fast forward now to a few weeks ago. We launched the photosynth app for iPhone, and the reason we did this was in order to try and start to crowdsource this more immersive view of environments, to try and get around the limitation of cameras, both handheld cameras and cameras on cell phones, which are, of course, almost the only kind of camera that people use nowadays, around field of view, because it's difficult to capture an environment using a camera that is essentially designed to capture somebody's face at a party. And to illustrate that, and we've been getting really good reviews, by the way. So we launched, in our first week, we got 1,000 or so ratings, 5 stars. It continues to be really strong. I just took this screenshot this morning, so we're up to 2161 ratings, and people are really enjoying this app, which is gratifying. All right, so this is a view captured out my window with the photosynth app, and actually it's not my window, it's my office. But anyway. So this is almost a full 180 degrees. It's almost a full half sphere. And so you see a little bit of this distortion, and we'll talk about that in a moment, right? When you flatten something that's an entire half sphere out into a plane, of course you've got to break some eggs. That's a little bit like cartography. But this is the kind of view that you absolutely can't capture in a single image with a camera. you'll very much be seeing the trees instead of the forest if you take a single shot. And in fact, last night we did a little experiment to show this at our friend Dave and Petra's Dave's birthday party. Dave and Petra live up here in the very top pyramid of the Smith Tower in Seattle, which is just about the coolest freaking apartment imaginable. And notice that right here at the very top, the cherry on top of the Smith Tower is this little glowing thing. And we were up in there, as we often are. And that's the picture. All right, so that's my wife and kids. And that's kind of what you can do, with the camera at one side of the cherry, shooting across to the other side of the cherry. And you see the faces, right? These cameras are good at faces, but they're not good at the environment. So how do you capture the environment? That is a flattened out pano that I took just like this with my phone up there. And if we want to look at it immersively, we can do that on the photosynth site. All right, so I did it really quickly, so the stitch isn't perfect, but this is a very, very different experience, right, from what you can do with with just a single photo. All right, so that gives you a bit of a sense of the difference between immersion and ordinary photography. It's panorama, really. Now, when you flatten things out, of course, you get these strange effects. This is a picture that everybody knows. We all find it very familiar because we see flattened maps of the Earth all the time. Of course, the problem of flattening out a panorama into a flat image is the same as the problem of flattening out a map of the Earth onto a plane, right? It's a sphere. You flatten it to a plane. And so we're all used to the idea of Greenland being about twice as big as the continental United States, when in fact, as far as I know, it's more like about twice as big as Texas. But that's what happens when you flatten things out. Of course, the Earth doesn't tend to have straight lines and architectural elements in it, so we're not as disturbed by this as we are by this, for example, which is a flattened out panorama that I took at the Neues Museum in Berlin. Right, so all this straight architectural elements turn to curves. I think it's actually quite beautiful, but that's kind of what you get when you do these flattenings. Of course, when you experience them immersively, you get something very different. Okay, so after launch, we've been getting millions of downloads of this app, and people have been taking panos all over the world. Some of them, of course, they just are just for themselves, or they just share with friends, or they post to Facebook or whatever. And some of them they post back to Bing Maps, which is pretty cool because when they go to the mapping site, then they become spatially explorable and visible by everybody, and that's one of the borders that we'd like to keep on pushing and pushing. All right, so now let's talk a little bit. Let's take a step back and talk a little bit about some of the different sorts of imagery that Microsoft is collecting. So this is most importantly aerial imagery. And oblique aerial imagery and street side imagery, and this project called the UltraCam G that we've just released over the past year in partnership with Digital Globe. So this is the way it works. This is the way it looks. It's a mapping. So the UltraCam G project in particular, this global ortho product, is the most ambitious aerial mapping exercise that I think has ever been undertaken, as far as I know, and it covers the U.S. and Europe at very, very high resolution from the air, and it does it in this very efficient manner with this very optimized camera. I should have pulled in a picture of the camera, but it's a giant thing. It's the size of a person, and it mounts to the bottom of a plane. It can fly at high altitude in order to cover large areas at a time. And we're doing this much more economically than say the U.S. government did with the digital ortho quad program, which cost many times as much and didn't generate as good of data. And these are the kinds of resolutions that we'll be getting everywhere. So you may be used to these kinds of images over cities, but thinking about that kind of resolution blanketing the entire U.S. and Europe is kind of a different order of thing. It's not satellite imagery, right? This is imagery that you can really only get from a plane. It's very high resolution. What you can also do is apply the same technologies that Photosynth uses for 3D reconstruction, and get digital surface models out. And these digital surface models are height fields that give you a three-dimensional reconstruction of the ground. So this is This is in a rural area around Vienna, and this is in the Vienna city center. The color here represents height, represents elevation. And when you have this elevation map, including all of the buildings, then of course you can kind of go. So that shows you the imagery and the elevation. Some rugged terrain, a farm area. You get the idea. When you have this kind of information, you can also do things like apply certain kinds of image understanding algorithms and classify the terrain into water and vegetation and hard surfaces, and then extract from that what is called digital terrain model, meaning if you take away all of the buildings and all of the surface structures, what's the shape of the underlying earth? That's the DSM versus the DTM, the digital terrain model. And that's the classification, the land use classification you can make out of that. And from that you can then extract building footprints, and from the building footprints you can extract three-dimensional buildings and so on. So all of that processing is happening now all throughout the US and Europe. That's pretty cool. But we think about that really as just sort of a lattice, or we've used the word trellis, right, or a canvas. It's detailed, but it's not anywhere close to as detailed as what you would see, when you take, well, it's not like, if we go back, these sorts of images, right? These are the kinds of images that no company is ever going to take, and that no company ever should take. These are the kinds of images that people are going to be taking and sharing with each other and posting and commenting on and so on. And the idea is to think about how these media that people take and share connect with the stuff that's blanketing everything at lower resolution, and that forms this kind of trellis that allows everything to connect. So its main value is as a connector. One of the interesting things that we discovered when we first launched Photosynth, by the way, is that we were expecting a lot of that very small-scale, ground-level stuff. We were surprised by how many people began shooting photosynths from the air. There was a whole little community that built up of people flying planes in unmanned aerial vehicles and in kites and in hot air balloons and just hanging out of planes. I hope they were doing that safely, I don't know. And taking shots out of planes and making these aerial synths. And at some point, more than 10% of the photosynths on the site were actually taken from the air. They're pretty amazing, and they can cover very large areas. This map has improved since, but in 2008, our map of Primosten, Croatia, was really pretty crap. Like the road doesn't even fall entirely, within the land polygon here. And this is superimposed the point cloud of one person's photosynth of this particular little peninsula in Croatia, taken from the air. And it has entire islands and things that are not visible on the map. And those aerial photos are more detailed than what we can shoot out of planes. And I think this was just done with an SLR camera out the side of a Cessna. So that's pretty cool. When we think about all of those different sorts of media, we think about everything from map tiles themselves, which you can think about as just a large planar panorama that covers the entire Earth, to these nadir aerial imagery, to what we call synth view, which is this SimCity-like stitched oblique imagery that I gave you a little bit of a sense of in New York and Manhattan, to the bird's eye imagery, the street side imagery, the block view imagery, which I'll actually show you in a moment, the backpack cameras that we've started to develop so that you can walk indoors with one of these panoramic cameras and kind of sweep through entire indoors panoramically, and photosynths and these user-contributed panoramas and panoramas that we're getting that we're indexing from partners like Jeffrey Martin's 360 Cities, who I think make the most beautiful panoramas I've ever seen. It's a community of panoramic photographers. They're getting all their stuff indexed by us as well. Public Flickr photos, video streams, 3D models. Lots and lots of spatially connected pixels. And how the hell do you connect all of that stuff together? Right? So this is the challenge, and this is what we want to do with Read Write World. That's the point. There also, by the way, are a lot of different rendering platforms that we're interested in. So this is just a handful of them. There's of course regular old HTML, And there are more advanced forms of HTML, like using Canvas and using CSS3 and using WebGL and so on. There's Windows Phone, Silverlight, iPhone, Android, RIM, Windows Native, who knows, right? So it's a lot of features, if you think about all of those as features. And we haven't even scratched the surface in terms of number of different sorts of some particular form of imagery showing up on some particular platform. Our coverage is still quite low here. And if you think about all those features and engineering that has to happen individually one by one, it's going to take us a really long time to really bring the value of all of those things and the connections, most of all, between all of those things out into the public. So what we're doing right now is consolidating and focusing our engineering on knocking out entire rows and columns of this matrix at once, using the read-write world concepts. So to be clear, there are three things that we want to converge with respect to all of these different forms of media. One is the metadata that expresses what some particular thing is. So we're not concerned with taking all of the actual bits of those images and bringing them all together into one place. They'll never be all together in one place. The map tiles will be hosted out of Microsoft servers and Nokia servers and so on. The imagery likewise, the aerial imagery likewise. Flickr photos are going to be hosted at Flickr. 360 Cities pictures will probably be hosted at 360 Cities, and so on. So the actual imagery and the pixels will be all throughout the world, but the metadata about what all of those are represented uniformly, what's their connection to the coordinate system of the Earth or some other coordinate system, what's the rights, what are the digital rights structures of these things? Are they Creative Commons? Are they copyrighted by somebody, by who? Are they in the public domain? The semantic connection between a piece of media and a place that is maybe named but not defined geometrically, like a business. The visual relationships between that and the people who captured it or the people who commented on it in some other way. All of that is the metadata, and we want to really think about the metadata expressed in a completely uniform way. And what we've done in order to further that is to develop this thing called RML, Real World Markup Language. Avi Bar-Zev has been really the main architect of that. KML was his idea originally as well, we could talk for a long time about all the technical details of RML, but that's maybe for another time. So converge the metadata, converge the services, and what I mean by the services is, it's all fine and well for the metadata to be all converged, but if there isn't a single API that you can call to ask what's available in this place, what's connected with this environment, then that's no good, right? You have to have an index. And this is in the same sense that the value of the web is only unlocked if it's indexed by a search engine, right? Then you have a place you can go to find something. So similarly, we're converging surface for all of these things. And finally, the viewer has to converge. You have to think about single viewers that can view all of these different sorts of things, or that can dynamically load bits and pieces to view all of these sorts of things. And I'd also like to think about those viewers as open source. So that's likely the direction that we're going to be going. I don't think that there's any value for Microsoft in keeping those things closed off. The more they get mashed up, the more they get used, the more they get repurposed for other things, the better, as far as I'm concerned. So if we do it right, if we do it once and we do it right, then instead of having lots of different disparate web services and lots of different disparate representations for these things, we can instead think about a single service that has some interesting new properties that the existing services don't, like read-write. And what I mean by read-write is that anybody can either consume or produce or write back into the thing, and real-time, so that if I write into it, then the writing is, whatever I've just written is available instantaneously. When we first launched this at Where 2.0 a few weeks ago, we actually had two machines on the stage, and on one machine we were dragging the position of a photo, and on the other machine you were seeing the position of that photo updating in real time. So it's real time. Uniformly represented rights, open source viewers, mashup friendly. So I'll give you a bit of a demo of our first prototype viewer for this stuff and how it works. So this is just doing a spatial query for photos connected with this place, but actually, since we're running low on time, I'll just stick with showing you a little sample of street slide that we've connected to this environment and a couple of other connections. So this is this little strip that's standing on top of the map is street slide, which is a panorama that's been fused, a strip panorama that's been fused from lots of sideways-facing images, sideways-facing panoramas that we captured as we went down the street. And in this case, when you have two different images, you have a flat panorama of the map and this flat panorama of the street. You can connect and transition them just by just by moving the camera and crossfading, and that's sort of one level of transition, if you'd like, between two forms of media. This, by the way, is this block view stuff is pretty efficient on mobile devices. That's really why we originally developed it. It's low bandwidth to pan and zoom back and forth and explore the entire block, whereas if you're in an immersed panorama, you can't see 40 meters down the street. So if your position is a little bit off, it's actually hard to figure out where you should go. And down by here is one of my favorite third wave coffee shops in downtown Seattle, Trabant. And we have some photosynth panoramas taken in the interior of this thing. When you run these computer vision algorithms and connect the inside and the outside, then you can generate automatically a video transition between the two, which is what we did here. So this is from the block view to the street side to an interior panorama. And that video is something that we haven't actually put the web service up yet, but we will soon. Whenever you can form a visual connection of the sort that photosynth can form, you can just synthesize one of those videos. And so now you start thinking about this as more like, it's not just a map, it's really sort of a graph. If you think about a social graph as being like a graph of people connected by friend relationships or follow relationships, this is a graph of media connected by semantic or visual or spatial relationships to each other. So this is this one panorama. There's another panorama in the back of the cafe, and again, visual connection formed between the two of them. Video synthesized. In this case, there were a couple of intermediate frames as well. Back to the front of the cafe. And over here, on the wall, there's a detail shot as well. So this is just a single image. And notice that this detail shot, so we have this little copyright in the bottom left. So this is copyright Lauren Aldrich, the artist who made this thing. So this is her media. This is her piece of media. And when we pull back out, this is now David's piece of media, because this is copyright David on photos. Actually, this is not copyright. This is a Creative Commons pano, so that it can be remixed and used by anybody. And of course, if we go back out to the street, then this piece of media, the block view, is copyright by Microsoft, and you can use it as a mashup creator, as long as you don't go above some large volume where you get into kind of commercial, large-scale commercial applications. So, and then we pull finally back out to the map. Right, so that's the basic sense. This user experience or this UI is by no means final or unique in any way. I can imagine tons of different sorts of user experiences that exploit this graph and exploit this real-time connection between media and space. But this just gives you a bit of a visceral sense for how such a graph works, to allow you to navigate from thing to thing and to enable all sorts of different interactions and different applications. So one of the things that this relies on is being able to form a visual match between an image or a piece of media and another piece of media that's already in the database. And so one of those fundamental magical services that we're exposing is something that allows you to query using an image and find the match. So go from this street side panorama near Pike Place Market and establish the match to this Flickr image like so. And so we demoed this at TED a year ago, the ability to take these Flickr images and match them to street side, but it was a little bit like the first demos that we gave of photosynth before 2008, so back in late 2006, 2007. At that point, you know, we were showing these synths of Notre Dame Cathedral. They actually took 2 weeks of compute time to make on clusters of hundreds of cores. And you know, by the time we finally got it to product in 2008, we were able to make similar synths in less than the time that it took just to upload those pictures on a laptop. So that transition from really kind of labware and demoware into something that's fully scalable and production ready and ready for prime time is a major transition. And we're pretty much there now with respect to this matching. We're close to there, and we're at the point where we can do it in real time. So on the readwriteworld.net alpha site, there's a page called Location Matching Explorer. You can just put a URL in of a picture, and it'll come back with any matches within seconds that are in the database already. And what's more, whatever you query with is also added to the database. So unless you explicitly tell it not to add it. And what that means is that if I take a photo of, I don't know, of some corner of my desk, right, that's not indexed yet, then of course it'll come back with no matches, probably, if it works. But if I then take a somewhat different photo of that same corner of my desk, then the photo that I just queried with will come back as one of the results. So it's the sense of continuously aggregating world index. Right? Just like you think about an aggregating index of web pages, this is now an aggregating index of media. So the thought that I'll leave you with, the last kind of concluding thought, and then we can take some questions, is that hidden in everything that I've been showing you today are two fundamental capabilities that are needed for strong augmented reality. I haven't actually showed anything that is augmented reality. Augmented reality is when you're in a place and you're looking through a frame of some sort and seeing content mashed up on top of the video stream or on top of the image. I haven't actually shown you that here, but I have shown you the two key ingredients for making that happen. And I'm not talking about the weak form of augmented reality that's just about using the compass and the GPS to approximately say, you know, I think the subway station is roughly in that direction. I'm going to put it on the video stream to make it look cool, but really it's just the compass and GPS. You know, I'm talking about strong augmented reality, which is where the image that you're looking at through your viewfinder or through your frame is dynamically matched to a model of the world, and it's decorated in a way that the things that you're seeing really pertain to what you're actually seeing in the video or in the video stream or in real life. The two things that you need are basically the keyframe operation, which is this, right? This is where you take an initial image and you say, what does it match against? Come back, here it is. Once I know what it matches against, then I know exactly how it connects to any kind of other information we have about the world in that spot. And the other operation that you need is tracking. And real-time tracking is, as I move, how can I figure out exactly how the view is changing in the viewfinder, right? And every once in a while you requery with a keyframe, but that tracking is essential too if you want everything to stick properly to the video frame and do the whole William Gibson thing. And that's actually the technology that we launched in the Photosynth Panorama Maker on the phone. It's unlike other panorama makers. You don't take a bunch of photos and then it stitches them offline. As you're moving the viewfinder, it's tracking and snap, snap, snap. It actually snaps the photos itself as you rotate, and you can see that on the screen. So that is the tracking operation working on a low-power ARM processor on the phone. So those are the two ingredients you need for strong AR, and that's one of the many applications that we're really excited about as we move forward with this stuff. All right, so I think this is the right time to shift over. We have a few minutes left for if anybody has any questions. Uh-huh. I think we're gonna move a mic over there so that everybody can hear.
Oh, thanks. I think your work is great, and I see the usefulness of it. I was wondering if you've given some thought to privacy issues and if there's a process for excluding your property from being digitized.
Yes. So the privacy question often comes up, and it's a really interesting one, and I could talk for an hour on privacy alone, but I'll try to keep my comments about this brief. So there are a couple of different angles on privacy questions. Some of them come up in the context of personalization with Bing Mobile and so on that are quite distinct. Let's only talk about the privacy issues that have to do with imagery, since that's really where the read-write world is focusing. So this is exactly parallel with respect to individual people's media to web search. Now, there's this additional component, which is the imagery that is captured on the street, right, with the panoramic cameras that Microsoft drives. You know, Google has run into privacy issues in Germany, for example, over such things. And some of you may know they also had to redrive all of Japan because originally the thing was too high and it was able to see over people's backyards, and they had to lower it and drive again. It was a bit of a fiasco. So there are, of course, every country has rules about that sort of stuff. And Microsoft in particular is extremely conservative, is much more conservative than Google, in fact, about following those rules and working with local authorities and so on. But fundamentally, that stuff that's driven by Microsoft or walked by Microsoft, we have to be very, very careful about, and it only happens in public spaces. And let me put it this way, the level of actual privacy violations that happen in the course of that is so low. You know, we've had a mechanism for stuff to be taken down on street side in place since we launched it, and we've had almost nothing actually taken down. And I think even the takedowns on Google's site in Germany are largely politically motivated, or you know, they're in principle as opposed to in practice. So it isn't actually a thing that wasn't visible to anybody who might walk by. What's more interesting is when you start going indoors and you start getting into spaces that are not public. We have no intention of going into spaces that are not public. And in fact, I'm not even particularly interested in that drive-by panoramic photography in suburban neighborhoods or around houses. I'm much more interested in the systematic street side capture in downtowns and around businesses, because those are the places where you really want that trellis and that connection. And those spaces, of course, are all about being visible and being public and being part of the public sphere. So you know, driving by houses and taking lots of photos of the front lawn is not interesting commercially, unless the person who is living there is renting their house or is doing something, you know, that they want shared. And if they want it shared, then they're going to be able to do a lot better a job of it themselves than we'd be able to do driving by at some random time, right? And then the imagery is going to be 3 years old or whatever. So if we think about the privacy implications of indexing people's images, I think this is a lot like the privacy implications of indexing web pages. And there was a time before web search engines worked well when people were putting some stuff up on the web, and I guess it still happens, that was private, and they thought, you know, well, you know, probably nobody will find it, so it doesn't matter, you know, if I document my sex life in detail and so on. And of course, it's the web. I mean, you just type in the damn URL and, you know, you get to it. What you do by indexing it, of course, is you add a tremendous amount of value. You make things discoverable and searchable. You can also exclude things from searching if you want to obfuscate them with a, you know, robots.txt type approach. You can do the same exact sort of thing with images. We don't want to be crawling or indexing anything that people didn't want crawled or indexed. But making it available and connecting it to other things is, in my view, exactly the same thing as indexing the documents of web pages and making them accessible by search. It's an explore-based as opposed to a search-based form of exploration. It's fundamentally the same thing. It's just about whether you're navigating a spatial graph. So I hope that didn't sound too glib. I hope that addressed the main issues. I'm very happy to talk about this in more detail afterwards, if you'd like. Anything else?
Okay. Blaise, you talked about a lot about the spatial dimension in your work. Are you integrating or considering integrating a temporal dimension into your work as well?
Yes.
I can see that you could very easily do an animation through history of, say, building facades, or a construction site might be an interesting kind of thing where you have a lot of change in a short period of time.
Yes, very much. So that temporal aspect is super interesting, and you know, there is, just by happenstance, plenty of historical imagery, you know, already around, even already in our data sets that we've put on the site. We might be able to find one if we're lucky. Here in Pike Place Market. So just the presence of historical imagery there, of course, alone is not enough. What you really want is to be able to explore things based on time. You'd like to be able to go and time travel in addition to space travel, which I think is what you're kind of hinting at. So absolutely, I mean, adding time in the right way to the metadata is, I think, essential. And being able to use the time to navigate, to create experiences, those are exactly the sort of mashups that we're imagining read-write worlds to enable. So really, the question is, is it in the metadata? Are you able to explore it that way? And are people interested enough to make experiences that are based on that? So yeah, I'm seeing here lots of images from 2007 on. There are, for sure, historic images too, but because we don't have a temporal navigation experience here, I'm not seeing. Here we go. This one looks like it's turn of the last century. All right, and there was just enough here to match against current day Pike Place Market. So that's kind of cool. Rephotography, right? 100 years separated at a time. Anyone else?
Ready? Okay. Hi. Greg Nudelman, Design Caffeine. I'm a huge fan of your work. In fact, I have a whole chapter devoted in the book just to kind of exploring photosynth and related technologies.
That's wonderful, thank you.
But I'm curious about, you mentioned some augmented reality applications, especially with respect to the tablet with the dual camera.
Yeah.
What kind of possibilities do you see as a creator of this?
The sky's the limit. I mean, I think that those are exactly the sorts of things that, we're going to be doing both things in our teams in Bing Mobile and Bing Maps. We'll be both developing platforms and opening up as much as we can, and also developing applications that that we think might be killer apps or might be really cool or might take off. But in that sense, we are both a platform developer and we're a bunch of little startups trying to make little apps. We put together a small team, make an app. I have no more or less faith in our ability to make cool, killer apps that way than in anybody else. So, that's why I think it's so important to really finally nail the platform aspect of this properly, so that others can come. And I fully expect that the killerest of apps will come from outside Microsoft. Yeah, of course I have my own thoughts about cool ideas, but I have to be secretive in my startup mode about those things, right? So we'll try a couple of things, and I don't know if they'll be the ones that take off in the end. I'm not sure.
Hi, I was curious about what kinds of people use photosynth.
Geeks.
Whether there's in terms of gender or age, and if there's particular kinds of people that you would like to outreach to you would like to be using photosynth but aren't currently.
Sure. So I think that and I don't know, this is all speculation because we haven't really done proper ethnography around photosynth users. But my speculation is that the original demographic of photosynth, the website, from 2008 onward, where you take the photos and you reconstruct these three-dimensional environments and so on, is people who like subscribe to the TechCrunch feed, and so on. I don't even know what the new TechCrunch is, but those sorts of people, and photography enthusiasts of a certain postmodern ilk. What we're trying, of course, what we're trying to do is to bring these things from whenever you do something like this early on, the first applications tend to be more demo-like, more forward-looking, more geeky, more techy, and then it goes mainstream and it becomes part of people's lives, a part of ordinary people's lives, and we're trying to make that transition. I think that the photosynth app for the phone is being used by a much broader range of people. So I've been really, really happy looking at all of the comments and things. The reason I'm so excited and so proud of the team when I look at the comments on the App Store about the photosynth app is that it really looks like a lot of regular people are just starting to use this thing because it addresses this very fundamental limitation of their camera. They just think about it as an extension to the camera. So just as extensions to camera, extensions to my ability to document experiences for the usual reasons that I document experiences, to share with my friends or just to have on my hard drive or whatever, I think that's extending into ordinary people. When I think about all of the collective applications, right, that involve contribution to the map, that involve this, this sort of hive mind of imagery, I think that there are people who naturally share with everybody and post, natural tweeters, if you like, as opposed to Facebookers. And I imagine extending in those directions. And I hope that with the right sorts of killer apps, we can encourage a lot of ordinary people to do more of that, more of the tweeting versus the Facebooking, if you like.
Are there any viewing capabilities for viewing a photosynth beyond the limits of a two-dimensional screen? Like
Yeah.
So that you can see a three-dimensional panorama in a half-sphere or a spherical viewing apparatus?
Yeah. So in a lot of cases, if you shoot a panorama with the current phone app, we're not getting the depth out. We're not reconstructing a three-dimensional panorama. It is fundamentally two-dimensional. Although the fact that people don't hold the camera still, they don't hold the focus point completely fixed, does actually suggest some tantalizing possibilities for reconstructing 3D as we rotate. I think it's possible to do to some degree, especially in tight environments. Of course, if everything is far away, then 3D and 2D don't matter, right? It's all just at infinity. But at least you would like a ground plane, right? You'd like to be able to use the ground plane to morph between things and so on. So yeah, it's very interesting to think about how one could view these things in stereoscopic displays or other kinds of immersive displays. And the forms of data that we're going to be publishing with RML allow things like depth maps and disparity maps to be encoded in the images. So it allows all of that stuff to happen. And I fully expect that as 3D emerges as a dominant mechanism for viewing, the media are following, and we're already there with respect to the way we're representing the data. Yeah. Maybe one final? Mm-hmm.
Oh, sorry. Can you use it to take a picture of somebody's face and then search for other images of that person's face?
I'm trying to find where.
Over here.
Ah, right. Sorry. Can you take a photo of somebody's face and use it to find other pictures?
With your thing that you have that you can search for like images. Let's say I take a picture of you and I upload it. Would it find other images of you?
Maybe. So the matching technology behind that is a lot better at architectural things, at hard things, than at soft things like faces. And faces in particular are special. They're not generic. Face recognition technologies are a whole domain unto themselves because the truth is everybody's face kind of looks the same. As far as a computer is concerned, you really need to have what we have in our brains, which is specialized hardware or specialized algorithms that are just for faces to do a good job of face recognition. And it's a hard problem. Face recognition is not the kind of problem that I think is ever going to be soluble. And when I say ever, I make a very strong statement. I don't think it'll ever be soluble fully in the sense that I have 6 billion images of faces. I take a random face and I say, who is it? The space of faces is just too dense. There are too many people who look like each other. On the other hand, if it's more like, I think this is likely to be somebody in my social network or a friend of a friend, can I match against that? Then it's completely soluble. So there's plenty of face recognition applications for that sort of thing, but they don't actually rely on the same technology that we've developed here. It's a separate application. One thing, so maybe we take just one more, but I wanted to also mention before I forget and before I get off the stage that Yesenia from Microsoft is going to be running a session here on HTML5 technologies, and I would encourage any of you who are interested in this kind of stuff to attend that as well. A lot of the next generation viewing capabilities that we're building into Read-Write World are designed specifically to render on HTML5 platforms and not require native code, not require any of that sort of stuff. That's the way you really make mashup as well as possible. So encourage you all to go and see that. All right, so did that assignment, we're done? Okay. thank you all so much. Thanks for letting me open, and have a very fun conference.